Okay, so this is the file, the concrete Revit template. If you go to File, Save As, you find that you only can save it as a template. Okay, so it doesn't matter in this course. Even if you don't do it, I will accept if you submit a template, but it's better if we open a new project, create a new project. So make sure that you have this project. And then instead of inserting one of the default templates, browse the template, and it has to be in downloads. Okay, so open this one. And if you open this file, then you can save it, save as, and here you have the option to save it as a project. Okay. Again, using projects, it's better than using templates. It's more professional. There are things that you can do with projects that you can't do with templates. So please, for this course, it doesn't matter because you are not going to share this file with other companies or other whatever. But sharing projects is always better than sharing templates. So get used to doing this. If you find a template, open it as a project, and then you can save it as a project too. Okay, so if we're going to do this building, the first thing, the grid or the grid lines are very simple. We have 1, 2, 3 up to 11. The distance is 20 feet, and then we have A, B, C up to the G, and we have 20 feet. Okay, so we need a grid 20 by 20. So let's do this. Open architecture, grid lines. And then, so let's create the first one. There were things in this file that I have deleted. So if you have number 30 or whatever, make sure that your first grid line is number 1, and then you copy.
Can you put down that first grid line?
First one. It's architecture grid.
Okay.
Up there. Okay. So then copy and 20 and 20. So this is 1, 2, 3. This is all we have up to 11, but we are going to work with just a couple of modules, and then we will repeat those modules. So we have 1, 2, 3, and then we have to select another grid line here. And here, this is A. And now if we copy this one, 20, B, and 20, C. Okay, so this is the basic, the very basic grid. So we have up to 11 numbers and up to G with the letters. So we are just designing this corner. Okay, so then if we take this corner and we repeat it. About the levels. Here you see that on the east or in any elevation, we have levels, and those are the levels that the building has. Okay, so we have level 0. I don't like this actually. When I find something like that and I have level 1, it's 0. I don't know. I don't understand. So I always change the name of levels with the same name of the number that the level has. Okay, so level 0 is at the 0 level, and then I will name this as level 15. And this is level 27. And 39. Uh, 52. And 64. And this is where the, so level 64 is the last level, and these two levels are to create the pyramid. So we have level 70 and 76. This is not mandatory. You can do whatever you feel like, but I don't know. Sometimes level 3, what is it? Oh, it's level 30, so or level 27 or level. So I think if we do this, I think it's we can understand where we are. So those are the levels, and well, I'm going to show you how to fix this. Sometimes we create the grids and we have the levels there, and when we look at the 3D view, we see that we have grid lines and levels. Okay, if we want to fix this and we want to make sure that our building, it's always, or all the elements that these auxiliary elements, level, grid lines, they are always where our building has to be. I'm going to use the view where is it? Or manage. I don't know. There is something by the name of scope box, but I can't find it now. It's usually in view, but I think schedules, legends, grid lines. Okay, so I am inserting here the footings. So we have the wall, we have a column embedded here. We have the wall footing, we have the isolated footings. So sometimes we need to reinforce the footings where we have the wall. So what does it mean? Okay, if we have a wall in the basement, so that's the wall. For the wall, I'm going to need a footing. Okay, so that's the footing. And sometimes we reinforced this wall with these columns. And that's because we have columns like this and like this. Okay, so if these columns are coming from other floors, and here we have a wall, sometimes we have to reinforce this wall here lined up with the columns. So if we have this, we might need to reinforce the footing as well, because the load that we have in this part, it's always bigger than the load that we have in this wall. Okay, so we need some reinforcement here. So that's why sometimes we have to do this. We have to reinforce the wall, the footing, sorry. But if we look at this in a plan view, if we look at this in the plan view and we have the wall like this, and then another wall like that. Sometimes imagine that this lot is not mine. Okay, so what is mine is the lot that is within this wall. And this is another property. So this piece of land is not mine, and the other one is not mine. So in that case, we will have to use a footing that it's not centered. Okay, so we can use a footing that is like this and like this. I'm going to make it gray, and I'm going to move it back. Okay, there you go. So we might need a footing that it's not centered in the wall. that gives problems. So, well, gives problems. The structural engineer needs to know if the footing is going to be centered in the wall or not. So usually it's centered because it's easier. But if we can't do that because we can invade our neighbor's site, or imagine that we're building something within two different buildings, so we can dig in that building because we will affect their own foundations. So sometimes we have a footing that it's not centered. If in addition I have a column here, probably I might need to create another footing just for this column. So it has to be gray, and I'm going to send it back. Okay, so that might happen. First, I have a wall. The wall, I can't put this centered column footing, so it should be like this. But if this part of the site is not mine, then I need to line up the footing with the wall here. And then we need a reinforcement. So we might need to increase the size of the footing where the columns are. So if we have more columns, I might need this. Okay. Again, this is not something that the footings and foundations, nobody sees the foundation. So it's something that it's hidden. They have to be reliable. So do not save money on foundations precisely because, okay, nobody will see that. So if I save money, or if I use less concrete or less reinforcement that I need to, nobody will notice because it's buried and will be buried forever. Yeah, but if the foundations are not well done, you will have a lot of problems. Again, the building will not fall apart, but there will be cracks and there will be movements in the building, and people won't be happy. So do not save money on foundations and add extra material, and don't hesitate to add all the material that you need on the foundations. Anyway, we need to know that if we don't have any constraint and we can do centered footings, we can do that. If we have those constraints, we can always use a line. And if we have to line up the wall and the footing, let's use with wall faces. And let's try to do it again. Okay, now it works. And join elements. It doesn't work. Huh, interesting. Let me do this. Okay, at least with the isolated footings, it works. With this, it doesn't work. So I have to figure out why, if we use wall foundations, there should be an option to line up the wall to the footing itself, or the footing to the wall. But this is not what I want to do. Okay, I'll find out. But anyway, imagine that we have this issue, so we can line up the footings, the wall footing and the isolated footing. And in addition, we need beams. Okay, remember that we always need beams. Yes. To line up the footings or what?
Yeah,
you select something, you click here, align, and then select first the wall footing and then the isolated footing, and you can do this. but it should work with the wall. But I think I have to insert the family of footings that it's not a centered footing. Okay, so I think that means that I have to select a new family because in this case it doesn't work. Anyway, I have these footings here lined up. I'm going to select isolated footings here. If I want to change by pressing tab, you can change the orientation of the footing. Not tab, sorry, the space bar. If you press the space bar, you can change the orientation of the footing. And if we align this and this and this. Okay. Now, what about the thickness? Well, in this case, the thickness of the isolated footing is the same as the thickness of the wall footing. And this is what should happen. And now we need beams. We need to connect the isolated footings with beams. Okay, so I can go to structure, beam. I need a concrete rectangular beam. Let's use this one, 12 by 18. And then from this point to this point, and there you go. And now look at the 3D view. Okay, if everything has the same height, I think it works well. Sometimes those beams don't need to be that high, okay? So we can use the 12 by 12 for the beams. Okay, so that would be something acceptable. We save some concrete because concrete is quite expensive. So here we are saving like 6 inches of concrete all around the beams. So maybe it's worth it. And well, the function of these beams is to connect all the isolated footings so that at the end, everything works together. Okay, so if there's something that makes this footing to go down a little bit, well, it's somehow connected to the footings around, and this doesn't affect the rest of the building. If they weren't connected, if there's an extra load here, or there's some weakness in the soil here, and this column go down just an inch, so that inch will show up somewhere. Okay, so if we have columns here and one of the columns go 1 inch down, then the rest of the structure has to adapt, and we will end up having cracks around the column. It's not the end of the world, but nobody likes cracks in a wall. Like it looks like scary. Or are we going to die? No, you're not going to die. Is the building going to fall apart over the night when I'm sleeping? No, it hardly ever happens. But a crack shows up and people don't like it. Okay, do I have to live with this crack all my life? Yes, because I did something wrong with the foundations. Anyway, make sure that the foundations are well calculated, and not only the calculations, but when you go to the site, make sure that the reinforcement are in the right place and the size of the footings is the right size, because it's worth it. Okay, so you will save a lot of issues if foundations are good enough. Okay, so that's it. But if all the elements are there, if we have retaining walls with wall footings, if we have columns with isolated footings, then if everything is there, we are safe. Even if the size is not the correct one, but at least we need to know where the elements should be. Okay, so that's the if we go to the west elevation, well, the 3D view, we see all these elements. And now we need a floor, okay? Well, we need a floor, but first, since we are working with a concrete structure on level 15, because this is level 15, okay, so let's open level 15. And now here, we're going to work with beams. Again, we have to calculate that. We have here 12 by 12, 12 by 18, 12 by 24. Let's use this 12 by 18. And we need beams here, 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 and here. Okay, if we go to the 3D view, we need beams. Connected to that. We don't need beams where the walls are, because the wall can be considered as a beam itself, okay? But connecting columns, we need beams. And now we need a slab. Okay, so we can have like a continuous slab made of concrete, or we can have something different. Okay, so we can create beam systems made of concrete. Okay, so let's explore different options. Okay, so if we go to structure, beam system. So remember that with beam system, we can pick supports. So if we pick this one, first, beam system, I always forget set the work plane. So it's not level 0. We are on level 15 now. Now we can pick supports, 1, 2, 3, 4. If we just want the beam system on that square, we have to trim this. Okay, so make sure that it's a closed shape, closed rectangle or a closed square. And then in beam type, here we have, okay, so let's do this. It's going to be wrong, but let's do this. Okay. So the beam systems or the beam element of the beam system shouldn't be as big as the beam itself. Okay. But it works like a beam system. We can use this. So now we can edit the fixed spacing. It's 6. I'll go to fixed number better. So let's use 6 as a fixed number. Okay, so that looks better. But this is not acceptable because we might need another beam element because this is too much. Okay. We can design our own beam. So we can go to beam, we can edit type, and I'm going to duplicate this beam. It's not 12 by 18. So I want this beam to be, let's say, 6 by 12. And now dimensions, B, it's the horizontal dimension, H is the vertical dimension. So I want this to be 6 inches. And this is 1 foot. Then apply, okay. So now I have created a rectangular beam on these beams. I have created a rectangular beam 6 by 12. So now I can select the beam system, and in beam type, I can select the 6 by 12, and that looks much better. Okay, so this is the first option. We can have concrete beams, and we can have a beam system made of concrete beams, but the beams of the beam system should be smaller in size than the main beam of the system. Again, we have to calculate this, but as a rule of thumb, this is a good criteria. Now, when we're working with concrete structures, we can use this element, and then we can use prefabricated beams. So they have the name of concrete joists. Okay, so this is what we are doing. So they are prefabricated elements like this. So we have a beam, and then we have joists. So you see that there's a smaller beam going from this one to the other one. Okay, so those elements are prefabricated so we find things like that. Okay, so those are joists. So we have the beam, we place that joist at the top of one beam, at the top of the other beam, and then we need to fill this with something, with okay, with these volts. Right. This is it. Okay, so that's the drawing. That is the joist, and this is like a vault, just filling the gap between two joists. So if we want to see a real, well, this is a Revit file. So that will be the main beam with the reinforcement. Those are the joists, and those are the vaults. So why are we using this? Because the concrete is so heavy that if we cast a lot of concrete, construction will end up being too heavy. So we don't need that. Okay, so we can have the beam, then we can have the joists, and then we can have these bolts that are hollow. They are not solid bolts, and they are lighter. As you can see, they have, okay, so it's not a solid element. And then we, so that the resistant element is the joist itself. Okay, so this is not resisting, it's just covering the distance, the span between two joists that can be around 2 feet, something like that. Okay, so this is a way, and we can have ceramic vaults, or we can have concrete vaults, or sometimes to make it even lighter. Okay, so that's the thing. Those are the joists, and those are the vaults that are hollow, and then we tap the concrete, and we end up having like a solid floor, like a solid structure. Okay, sometimes those vaults are made of this element, expanded polystyrene. Okay, so those are this white foam. So that makes the element much lighter. Okay, it's not because of the thermal insulation, it's because we want to reduce the weight of that floor. Okay, so those vaults can be made of either ceramic, or they can be concrete elements, or they can be like this foam that makes the roof even lighter. Okay, anyway, that happens because the structure, and we can do this with steel beams too. Okay, so here you see that we have steel beams, steel joists, and then we have the bolts, between them. Okay, and then we cast the concrete here on. We cast the concrete, we cover everything, and then when the concrete gets solid, so everything is so everything works like one element. So we don't have beams, joists. When we cast the concrete, so everything is connected by this casted concrete. Okay, so that's it. For sure, we need a formwork. Okay, so we have this element. So this element, we can put the joists here, the bolts there, and then we cast the concrete, and everything gets together, works together. So that's an option, and in Europe, this is mainstream. Okay, so most of the residential buildings in Europe are made of these kind of concrete joists, and these vaults made of either ceramic or concrete or polystyrene, expanded polystyrene. There are other options. We have the waffle slab. What is a waffle slab? Well, I'm sure that you have seen this, especially in parking lots, in covered parking lots. You have seen this kind of ceilings. Okay, what's this? Those are two joist systems, two perpendicular joist systems. And we have these poles. And those are made of, so this is like another vault, but it's a vault that can be removed. Okay. So we have these nice ceilings. It's cool. They need a reinforcement. When we have a column, we need a reinforcement here. So you see that, well, here we can tell in this picture. Let me see if I can make it bigger. Okay, so you can tell that there are joists. This is solid concrete, and here we have removed those elements. So those elements, let me see if I can show you a picture. Okay, so that's the section. We have those voids, but when we cast the concrete, we have like this. Okay, so we have like these plastic elements, and when we cast the concrete and the concrete gets solid, we can remove those elements and then we can use it for another slab. Okay, but that's the idea. This guy is placing those elements. This is plastic, so they can be easily removed from the concrete. And then when we remove this element, what we see is the waffle slab there. Okay, but again, we always need a reinforcement where the column is. And that will be the, well, the top view. Okay, so there are different options. And then we have a solid slab. If we have a lot of, or the loads are very heavy in the building, we can't afford having these voids between different joists. And then we need a solid slab. Again, what is the best thing or what is the worst? I don't know. If we're not going to see the ceiling, probably the joists and the ceramic vaults or concrete vaults is the cheapest solution. When we do something like that, is because we want to see it. Okay, so that's nice, and people like it. Okay, so if we want a ceiling that it's exposed concrete, we can use this waffle slab with reinforcement where the column is. And if by calculation we need a solid slab, we have to use solid slabs. Okay, so there's some aesthetics decisions. So this is probably the most beautiful one. Then if aesthetics don't matter because we're going to hide the ceiling, if we have a false ceiling here and we don't see that, the one direction joists and the bolts, probably this is the cheapest. But when we have heavy loads on the building, we might need a solid slab. Anyway, let's imagine that we are going to expose the building. So how can I create a waffle slab? So I can do that by placing two beam systems. If we create another beam system, if we set the work plane on level 15, we pick supports the same 1, 2, 3, 4. We trim and we change the beam direction. Okay, so you see that the beam direction of this beam system is this one. I click OK, and now I need to put the fixed number with 6. Oh, and the beam element, it has to be the 6x12. Okay, so by doing this, I have a nice waffle slab. Okay, is there a family? Is there a waffle slab? Probably there's a family, but we have to download it. And okay, doesn't make sense. But well, it makes sense. But if we want to do something quickly, probably this is the best way to do it. Just using two beam systems perpendicular to each other, making sure that we have the same distance, because otherwise it won't be nice. Usually that works with squares, and that's it. Is that enough? Well, it's not enough, because we have to reinforce where the column is. So if we have to reinforce where the column is, I think I can use in architecture component model in place. I'm going to use floor. Okay. And I'm going to use extrusion. I'm going to set the work plane on level 15. And it's very simple, because I just have to draw this rectangle, click OK, and then make it. There you go. Whoop. Okay, so I have created a reinforcement here, and then I have to copy this element to copy. Here, here, and there. Okay, so now I have created that reinforcement, and if I copy everything now, if I copy the reinforcement and the first beam system, and now I want to copy the second beam system. Okay, let's select everything, filter. I want the structural beam systems. And now I want this, and this. Now copy. Okay, so you see that if I copy this 4 times, the part of the waffle slab that it's connected to the column, we have this reinforcement here. And again, that looks nice because just by taking a screenshot, if we place a camera here, okay, just by doing this in the basement, things get better. Okay, so it's not something. But if we have a ceiling that, oh, look at this ceiling, it has a waffle slab. Oh, and we have the reinforcement here where the column should be. Yes, you add like some beauty to something that can be dull or boring or whatever. But if you have a waffle slab, everybody likes it, and it looks cool. And it's quite easy to do. Okay, so just by combining two beam systems, that's enough. We have something missing because, as you can see now, we need to cover this. Okay, so it's empty. So we need a floor. So I'm going to on level 15. I'm going to create a floor. I can go to structure, and we have structural floors, and we have a 4-inch concrete floor. That's all we need. We can create the rectangle. And attach and see what we have done. Okay, let's look at the elevation. On the elevation, that's the floor. Okay, so that's going to filter only the floor. So I think it will work better if we move this floor like I have 5 floors. I want to move it 4 inches up. There you go. Or, well, I don't know. Yeah, I have moved that floor 4 inches up, but it could be embedded in the, well, it depends. The height we want here, yeah, I don't know. Anyway, this doesn't have to be more than 4 inches. So it doesn't have to be 1 foot floor because we have these joists. So this is what really, this is a structural element. Okay, so yeah, I think we can leave it that way, and we have a waffle slab here with reinforcements where the column is. So we need these solid elements. Remember that we always need reinforcements where we have the column. Louis Kahn, for example, this is the ceiling of another Louis Kahn's building, which is the art gallery. That we have just, this is not the building that we are modeling, it's a building that it's just opposite that building. So we have two Louis Kahn's building in New Haven. And okay, so that's the ceiling, but it's made of triangles instead of having the waffle slab. So we can do this with triangles, and it's always something nice. Okay, so having a exposed concrete ceiling, that it's not just a flat slab that has this, it's always something nice. So let's go to level 15, column 12 by 12. I want to work at grids. So I select these grids and those grids, and we have columns there. Let's go to the 3D view. And did I insert the column? Column. Okay, I think we have the Okay, so I have to select level 15. Where the hell is the column? Okay, so it's here. Again, it always has this base offset. So it has to be up to level 27. The base offset is 0. And now I think I can move it to the right place. Here. Okay. And now I can copy this one here. And now I can select 2, 3, copy. There you go. Okay, so first we have the columns. Second, we need the beams, but the beams are going to be on level 27. So I have to open level 27, and then I have to use the beams, the 12 by 18. And can I use the grids? Yes. Okay, so on the 3D view, I have the beams, or okay, because I'm going to copy everything. So on the east elevation, I'm going to copy everything, the beams, the slab, and the joists. So I select this, I copy. Sometimes if you want to copy floors, you can do it because you have this constraint on, so you have to remove constraint, and then you can move it up. There you go. Okay, so once we have created one of the modules, we can keep copying things. The only thing we have to make sure that the columns have the same height. So if the levels are all the same, we can copy these 5 or 6 floors or whatever. If they are not the same, then we will have to change the size of the columns, and then we can copy the floors with all the joints and the beam systems there. Okay. So what's next? We can continue this until the roof, and then for the roof we can create something special, or we can try to understand the elements that make the drainage or the building drainage here. Okay, so remember that we have this wall, the basement wall, we have the footing here, and then we have to create all these layers to get rid of water. Okay, let's do this as a 3D object, and then another goal of this exercise is to work with callouts. Okay, so to create our own details in 2D. But I think the more things we do with 3D objects, I think the better. So let's try to do this. Okay, so we have the basement wall, we have the footing. So we are going to create these elements, and with this drainage pipe here beside the footing. Okay, so here we have different details, different options, but it's always the same. So this is it. If we have the wall, then we have to protect the wall with waterproofing. Then we have to dig a ditch here, and then we have to put the drainage at the bottom of this, and then we have to refill this with aggregates, and then we will have the soil. Okay, so let's do this in Revit in 3D, and then on Friday we will continue the structure and we will work with the roof. But today we're going to work on this. We're going to work on the waterproofing elements that we have in this in the basement wall. Okay. Okay, so what are the components here? We have a drainage, we have a pipe here. It can rest on the footing, and then we need to create elements for waterproofing to protect the wall, and then we have to use the aggregates. So there are different layers, so we're going to do different layers as in 3D. Okay, let's do that. First, we can work with the east or west elevation. Okay, so we're going to work with the, no, let me see. Okay, let's work with the south elevation. And in the south elevation, we are going to start everything on grid C. Okay, so according to my drawing, this is A, B, C. So I want to see the south elevation, and I'm going to start all my elements on grid C. So let's go to the south elevation, and I'm going to use the option architecture component model in place. So in architecture component model in place, what is this? So we can say that this is topography. Well, it's related to the soil, so let's call all this topography. Okay. So the first, we're going to use by extrusion. And I'm going to create the soil. So I'm on grid C, so I'm going to pick the plane or select a grid C. And now I'm going to draw the soil. So if this is the wall footing, so I'm going to do this. And I'm going to create like this trench, this triangle here. And then I'm going to do this. There you go. So it's just the shape of the soil. Okay. So we can click OK. And then on the 3D view, we can drag this in this direction. Okay, so I have created the soil. By the way, I don't have a floor on the basement. Okay, so let's go to level 0 because I don't have a floor on the basement. So that floor, the basement floor, doesn't have to be a walkable slab, basically, because we're not going to see that. So I'm going to create structure floor. We need more than let's say the 6-inch concrete floor. And now I'm going to create a rectangle, but now it has to be within the wall. Okay, so I need to select this corner and up to this corner here, and then click OK. And I do have a floor here on the basement. So now the soil, I can edit in place. I can edit extrusion. So now that soil, I have to move this 6 inches down. There you go. Okay, because I want the soil, I want to stop the soil where the concrete starts. Okay, so this is a 6-inch concrete slab. And now the soil has to be, yeah, just 6 inches less. Okay, so now we have a floor to the basement. The floor is made of concrete, and then after the floor, we start with the soil. And we have created this because I want to create this. If you see this, we always have a triangle. Okay, so I'm going to do this. This is the soil that I have just done. Now I'm going to create that triangle that is going to be filled with aggregates. And now I'm going to do this. Drainage. Again, you can dig this and then put the drainage at the bottom of that and cover, but I think it's better if we create like a base or something to rest the drainage pipe. It will be, yes, so you see that here we have this drainage, but we have created like this so that the V shape can be adapted to this, okay? So it's not just throwing the drainage pipe. No, we have created a support and that protects this drainage pipe. So I'm going to do this in Revit. So I'm opening the south elevation again. So here I'm going to create like a shape to place the drainage pipe. So what is the size of this drainage pipe? It can be 6 inches, the diameter can be, no, the radius can be 6 inches. Okay, so I'm going to go to architecture component, model in place. And this is plumbing, yeah, something related to plumbing. And I'm going to do by extrusion, starting on grid C. I'm going to create a circle like here. And the radius of that circle, it's 6 inches. Well, not 6 feet, 6 feet, sorry. 6 inches. It's too big. Okay, so I'm going to make it 4 inches. Okay, that works. So with this 4 inch, now I'm going to trace the shape that I have here. So I'm going to select line. So I'm going to create that shape here. Now I'm going to do this. And I want to create the negative of this circle. Okay, so I want to create that shape. So I'm going to break the circle. So to do that, I can use this split element. Okay, so if I select the split element and I click here, now I have broken this circle. And now I can trim this line and that line. There you go. But now I need another line here. And now I can trim this one and that one. Okay, nice. So if I click that, then I can go to the 3D view. And in wireframe, I can move this in this direction. Okay, so I have created like something to put the drainage pipe there. So that will be safer. The pipe won't move if you fill it with aggregates or soil or whatever. So it will be safer. Okay, so this is it. I have the soil, then I have this element to fix the pipe, and now I need to create the pipe itself. So again, architecture, component, model in place. This is plumbing. So I will select extrusion, pick the plane grid C. And now I need another circle. So I need this center. If I can't pick the center, I need the diameter and then a circle. And now I have this. Okay, so I need just need this circle, click OK, and go to the 3D view. Look. And drag this all the way. Okay, the soil, then that element, and then the pipe. So what's next? We need the waterproof for the wall. Okay, so we need a layer to protect the wall. So what's that? We can have paintings, but paintings for waterproofing a basement wall is not enough. We need a waterproof basement protection. So let me, okay, so that is the element. So this is like a plastic element. So we put this on the wall. First, we place the painting for waterproofing, or the asphalt. And then we place this because we're going to cast soil on the waterproofing. The waterproofing is something that can be thrown very easily. So that's why we need this plastic protection. Okay. So let me see if we can see one of the details. Yep. This is it. Okay, so you see how we use that element to protect. Well, the picture is small, but you see that we have this trench, we have the pipe at the bottom, then we are filling this with aggregates. So to protect the waterproof element from these aggregates, we have this plastic element there. Okay, so here we have the same thing. This is a drain. We have to fill this with aggregates, and then to protect the drain, and no, to protect the waterproof that we have in the wall, we have this element here, this plastic element here. Okay, so waterproofing a basement wall, it's quite difficult. Okay, and you can see here that this. So this is the plastic element, and we have to fix this to the wall, and then somehow we have to protect with a flashing. We have to protect, so we have to prevent water from going between the plastic element and the other. So it takes all these layers. You see that here we have the concrete wall, then we have different paintings, then we have asphalt, and then we have this protection, and finally we have the aggregates there. Okay? So it takes a lot of effort to protect the basement. So it's not okay with the basement, or we have the basement. Oh, let's put the basement. If we want to protect the basement, especially if we want to live there, if it's just a storage, probably waterproofing is not that important. But if we want to place a bedroom or something on the basement, we have to do a lot of stuff. And this is a summary of all the layers that we need. Okay, so we have the wall, the footing, then we have the first painting, then we have asphalt, then we have this protection, and then there is an extra layer to protect the protection. No, I think this is to prevent roots and plants affect the plastic elements. Okay, so this is something anti-roots for plants, but it takes a lot of effort to create a good detail for that. Okay, but this is always what we have: footing, walls, waterproof protection for the waterproof, and then we have the drainage here with this element that holds the drainage pipe, so the drainage pipe doesn't move when we are filling this with aggregates. Or I'm going to copy this detail because I think it explains. There you go. And okay, so what do we need here? We need to know that those things exist. So just keep in mind that we need an extra layer here. I'm going to go to architecture component model in place. What is this? Well, let's keep this plumbing. And now I want to go to extrusion, grid C. And I'm going to create a rectangle like here, protecting that. Okay, so here, this layer, it has the painting, the asphalt, and that element. And then we can go to the 3D view, select, and drag. Okay. And finally, where are we? South elevation. Yeah, so let's complete this filling. So let's go back to architecture, component, model in place. This is topography because this is soil and aggregates. And now I'm going to use extrusion, grid C. And now I can pick lines, okay? Because I have all these lines here. So I don't have to draw it again. I think I have selected this twice. Pick lines. This, that, and this. Now I can trim. And finally, I want to connect these two. And on the 3D view, I want to drag. Okay, so now you have all the elements that make up the waterproofing system of a basement. So as you see, it's there are a lot of elements there. Okay, so what's the beauty of having a 3D view? That now we can control this, and we can show like different in different layers. We can show like all the elements that we have here. Okay, so if we drag these elements, here I have the filling, the aggregates. Here we have the soil. Here we have this. Here we have the pipe, and here we have the waterproof layers, and here we have the concrete basement wall. Okay, so if I want to do this detail, I can do it with Revit just by, okay, so now I can type all the elements that I have in this. Another good point about this is that if I'm on level 0 and I just take a section, view section. So if I take a section of this building, in this section 1, well, we have all the elements. Probably we can see the topography because in visibility graphics, topography is not activated. Okay, so when I take a section, I see all these elements. So that's the good thing of doing this as a 3D object or a 3D